All right, guys, today we got graphing linear inequalities in two variables. The equations are going to look like this or that. Yes, the equations could be equal to also or equal to also. Not equations, but inequalities. We've graphed inequalities before, but we did it with one variable where we graphed a number line and shaded part of the number line. So when you get two variables, instead of having a number line, we're going to actually be looking at a coordinate plane. So that's one major difference. First thing we got to know is whether points work, because that's going to be part of our process here. Is we got to figure out whether any of these 4 points is a solution to this. Now, a solution means it's less than 6 when we plug it in. So if I plug in A, it would be like 5 times 0 minus 2 times negative 4. And if I work that out, that would just be 8. Now, is 8 less than or equal to 6? No, it's not. So that's not a solution. Let's try B. Plug in 2 for X and also 2 for Y. And that would give me 10 minus 4, which is 6. That would be a solution because it does say equal to 6, so that one's good. Let's try C. Plug in negative 3 for the X. Plug in 8 for the Y. And let's see what happens. That gives me negative 15 minus 16, which is negative 31. Is that less than negative 6? It sure is. That one works. Try the last one. Plug negative 1 in for the X. Let's plug negative 7 in for the Y. That'd give me negative 5 plus 14, which is 9. 9 is not less than 6, so that one doesn't work. And that's a big deal. That's one skill you're going to have before you can shade these things, is figuring out if a point works or not. And here's the steps we're going to do to graph these things. Step 1, we're going to act like the inequality says equals, and we're going to graph the line. If it's a just greater than or less than, it's going to be a broken line, or like your book calls it, a dashed line. If it has an equals with it, it's going to be a solid line. After you draw the line, we're going to pick a point that's not on the line, either somewhere over here or somewhere over here. Pick a point, plug it in. If it works, when we plug it in, if it is a solution, we're going to shade that side. If it doesn't work or it's not a solution, we would shade the other side. And I'll show you 2 or 3 here to let you see what we're talking about. Okay, the first couple here, really just one variable again, but they do want you to graph it on a coordinate plane. The first one says y is less than negative 3. Don't forget, if you just have a y, it is a horizontal line. It's going to be dashed or broken because there's no equal sign, so I'm going to go right through negative 3 on the y-axis. Now this one says less than negative 3. Obviously the points less than negative 3 are below the line, so you would shade down here below. I hope you can see that green, shading below that line. The second one says x is less than or equal to 2. So x, just an x is a vertical line. Notice I'm drawing a solid line right through x is 2 because it has equals. Now it also says less than 2. Less than 2 is everything over here, so I would shade that side of the line. Your answer to all of these is called half plane. It's a half plane because you're really shading half the coordinate plane whenever you shade every time. It may not look like it because our coordinate plane doesn't go forever like the real one does, but that's what you're doing. All right, graph y is greater than negative 2x. This is basically slope-intercept form, and the y-intercept is 0 because there's nothing after the negative 2x. The slope is negative 2, so I'm going to rise negative 2 and run 1 to right here. Your next thing you got to ask yourself is my line going to be solid or broken? This one's going to be broken because there's no equals here. So I'm going to try to draw the best one I can. Broken. As we go right through there. Now, you got to plug in a point, or you got to pick a point that's not on the line. You need to make sure it's not on the line. What I usually do is pick the easiest one I can. Usually, 9 times out of 10, I'm picking 0, 0, but this one goes through 0, 0. So I'm going to pick the next best thing. I'm going to pick this point right here, which is the point 1, 0. So I'm going to put a 0 for my y, a 1 for my x. I'm just plugging that point in. And when I do that, I get this. I get 0 is greater than negative 2. So I'm asking myself, is that true? Is 0 bigger than negative 2? And the answer is, yes, it is. So I'm going to shade this side of the line where that point is, because the point was a solution, which means everything on that side of the line is a solution. And you can pick any point up there you want to and try, and I promise you it'll work. And if you pick a point on this side, somewhere around in here, it will not work, or it will not be a solution. All right, a couple more here. This one, 5x minus 2y is less than or equal to negative 4. That's standard form. Here's what I know. I know, by just finding the y-intercept right there, if I cover up the 5x, I know that y-intercept is going to be 2 because if you divide by -4 by -2, you get 2. Now I know what you're thinking, gosh, you got to flip the sign. You would, but we're not actually trying to solve it. I'm just trying to find a point. So it's going to cross the y-axis at 2. Right, now the slope, remember the slope of this line is -a over b, which in this case would be -5 over -2, which is 5/2. So I'm going to start at that point, going to rise 5, 1, 2, 3, 4, 5, and run 2 to right there. There's my slope. I'm going to connect those dots with a solid line because there's an equal sign in there. So it's going to be a solid line. Not a very good one, something like that. Now, again, to figure out which side to shade, pick a point that's not on that line. I'm going to pick this point as much as possible. 0, 0 is not on the line, so that's the one I'm going to pick. And if I plug it in, if I plug the 0 in for x and a 0 in for y, I would get, so it equals, it's less than that. I would get 0 on this side and -4 over here, which says 0 is less than -4. Now, before you jump on that too quickly, that is not true. 0 is not less than -4. It's actually greater than -4. So it's because the point was not a solution, I'm going to shade the other side, the side opposite of the point, that side over there. And that's all there is to it. One special case here, and that's absolute value. Don't forget the shape of absolute values of v. We know how to graph that now. What I have here is I have a shift of a right 3 and up 4. So I'm going to go right 3, up 4 to right there. That's where my v is going to be the vertex of my v. Now, in front is -2. That's a vertical, that's a one that's negative, which means it's going to reflect across the x-axis. It's going to go upside down. Also tells me the slope of my v is 2, so I'm going to go down 2 over 1, down 2 over 1. Now, you have to decide whether to draw a dashed v or a broken v or a solid v. And because there's an equal sign, it's going to be a solid v right through there. Okay, yeah, a solid v right through here. Now, when you're going to shade a v or an absolute value, you're either going to shade inside your v or you're going to shade outside the v. So you got to pick a point that's not on the v, and that's up to you. I'll tell you a great one to pick, because it's going to sound weird, is not necessarily 0, 0. A great point to pick is like directly below your vertex or above your vertex on the x-axis. That point right there is actually 3, 0. And watch what happens if I plug in 3, 0. My y becomes 0. Over here, if I plug in 3 in here, look what happens to my absolute value. And that will happen every time. I mean, that's just 3 minus 3 is 0. 0 times -2 is 0. So all that leaves is the 4. And if you pick that point, I promise you it's going to happen every time. So now ask yourself, is 0 bigger than 4? Hopefully your self says no. So you're not going to shade inside the V. You're going to shade outside your V shape on your whole coordinate plane. All right, and that would be those are all solutions out there. And that's all we're doing tomorrow is just, graphing inequalities with two variables. So it's a good practice for your graphing lines and graphing absolute values, just adding the shading and the broken and dashed line and plugging a point in. It's really all we're adding. So hopefully that wasn't too bad. I'll see you in class tomorrow. Can't wait to see you. See you. Bye.